Hi, everyone. Thank you for attending my talk. My name is Nicole Krause, and I am a PhD student and researcher at the University of Wisconsin-Madison. I am in the Department of Life Sciences Communication there, and I'm a member of a research group that's called Science, Media, and the Public, or SciMep for short. The research that we do focuses on public perceptions of controversial science, including the question of how science becomes controversial in the first place. So today I'm going to talk about some of the individual level psychological factors associated with people's acceptance or not of information about science. And I just want to say, as I share my screen, that there is a much bigger picture to consider as well, with social factors and structural factors that contribute to people's beliefs about science, but that is not the focus of my talk today, so just keep that in mind. Okay, so why are people misinformed about science? What individual level factors contribute to misperceptions? So we can think of two main perspectives here. The first is that individuals lack certain tools or that they have insufficient tools. So for example, we know people can often be ignorant of science simply because they have education or just they haven't been in school for a long time, or they may lack media literacy. So it's not about science, but it's about an ability to critically evaluate the sources of information that they might be encountering, for example, in social media spaces. These problems would require educational efforts to resolve, and it's possible that some of the other speakers will be talking about science education, for example, or even media literacy efforts. But also in this space, you can consider that people might have some of the skills, but they simply need assistance using them. So in that case, we can think of things like fact-checking services like Snopes.com or PolitiFact, that attempt to offer people assistance in wading through all the information they encounter. And some of those services are being integrated into social media too, with Facebook alerts that something that a user is seeing might be misinformation. So these are all important approaches, and there is certainly evidence that they do make a difference. However, there's a limit to what they can accomplish without some attention to this second perspective, which is what I'm going to talk about today. And this is about people's psychological tendencies. So there are tendencies in all of us that can make us susceptible to misinformation, even when we have the skills to know the truth. So not to diminish the first set of tools or first set of approaches, but just recognition that this is a tapestry of solutions that, that will be required to address science misperceptions. Okay, so to illustrate the point about psychological biases, even when we have knowledge, consider this study from Yale. So the graph on the left shows that as Americans' basic science comprehension goes up, they are more likely to provide the correct answer to this statement. True or false, human beings as we know them today developed from earlier species of animals. So that makes sense. And we can see on the right that if we break this down by levels of religiosity, that the individuals with higher religiosity in orange are less likely to provide the correct answer to this question. Interestingly, those with the highest levels of science intelligence actually become less likely to provide the correct answer. However, when the question stem is changed, so when nothing else about this survey changes except the addition of this statement, according to the theory of evolution, human beings as we know them, etc., is that true or false? Now we see the different religious groups come into alignment. So while we may have been misled by this previous graph to conclude like, oh, well, religious groups aren't providing the correct answer to this question, they must lack the correct answer. They must lack the facts, and they just don't know what scientists know about the theory of evolution, and we can tell them. We may have drawn that conclusion from this, but what we can see is that when religious groups are offered the opportunity to say, yes, I know that scientists believe this, then, and it doesn't necessarily require a statement from them that this is indeed what they accept as the truth about the world, then they do provide the correct answer. So what we're seeing here is potentially less about people not knowing, but rather they do know the facts, but they refuse to accept those facts as truth. So why does this happen? There are possibly many psychological explanations for this, but one that gets a lot of attention and it seems to be very useful in science communication contexts is this theory of cognitive dissonance. So this is the idea that individuals prefer consistency in their thoughts and their beliefs, and they will often protect themselves against inconsistent information. For simplicity, you can think of this like trying to put a square peg into a round hole. So this is a person receiving information about science that maybe doesn't align with what they already know, square peg, round hole. And the mind has different strategies for dealing with this problem. So one of those strategies is selective exposure, which is when we turn our attention disproportionately to the things or people that do tell us what we want to hear. So news sources, for example. And this has been shown to occur with both political and scientific topics. But it's worth noting that there's less evidence that people actively avoid information that they don't like. It's more that we are disproportionately drawn to information that is more confirmatory. So this has been called confirmation bias. And this happens often without us realizing. We just kind of pay more attention and are drawn more toward things that are like us or that agree with us. However, some other strategies aren't about exposure. They're actually about interpretation. So what happens if you do end up encountering something you disagree with? You haven't sort of directed your attention toward only the things that confirm, and you've ended up exposed to something that you might not want to hear. In this situation, this is often called motivated reasoning, the idea that all of us have a tendency to not necessarily always process information with an accuracy goal in mind. So when communicating about science, often we hope that we give people information and they will weigh that information in a sort of objective way to come to the most accurate possible conclusion. That in the end, that's what people want, is to have the truth to be accurate. That's not necessarily how people are motivated. People have other goals depending on the context. It's not always the same, and it can differ for different people. But we often are motivated to protect our reputations, for example, if we're in a highly social setting, or to protect our political and religious views that we strongly hold, and that our affiliations with those groups as a part of our identity. And so there are different ways that we do this. One is called disconfirmation bias, which is psychological experiments showing that individuals tend to more heavily criticize and counter-argue information that they don't like. People are capable of producing more arguments against the things that disagree with them, and they will in certain situations. Another is called biased assimilation. So this is basically when we evaluate as more convincing the information we do agree with, which allows us to, from a larger body of information that we're given, sort of extract the things that it's like, oh, well, they've said, I hear all those points, but what I agree with is this one, and that's the only piece I'm going to take away. So you assimilate information into your knowledge structure in a biased way that it's not comprehensive. So these tendencies have been demonstrated again and again in different political and scientific contexts. So maybe we would imagine this would happen for heavily politicized things like abortion, political topics that are heated, but this also has been shown to occur for things like science, even just when people are exposed to information about nanotechnology, human gene editing, stem cells, etc. So this is definitely something that applies even to scientists and those who communicate about it. One more point here is this idea of the backfire effect. So motivated reasoning can occur with all kinds of information, fact-based or not, but disturbingly, there's emerging evidence that communications which attempt to correct individuals' misperceptions by focusing heavily on the facts, basically telling a person, here is why you're wrong, here's what's right, that can often backfire. The explanation for that is this notion of motivated reasoning, but essentially the people end up digging further into their pre-existing views, which is the opposite of what we would want. More disturbingly, perhaps, is that this backfire effect and motivated reasoning more generally have been shown to occur basically be most pronounced among individuals with higher stocks of knowledge about the topic in question, especially in political, if the scientific issue is politicized. So you may think that intuitively individuals who are more educated about something or more well-versed in a particular knowledge domain would be more open-minded about information, or more able to think, or more willing to think critically about it and come to accurate conclusions, but it's actually often the opposite. And one explanation people have given for that is that these biased reasoning tendencies, disconfirmation bias and bias assimilation, actually are well served by having a strong argumentative ability. So the more able you are to counter-argue something you don't like, and the more able you are to recognize the parts of it, a message that align with what you believe and those that don't, and take only the pieces you want, obviously the more capable you will be of motivated reasoning. So slightly counterintuitive, but important to understand how these things can affect maybe the ways that we think we should be able to communicate about science, and actually might not work the way we expect it to. Okay, so I've talked a lot about how people's thoughts are, how people think about some of these things, and I have said less about how they feel. The affect and emotion is less my area of expertise, but there are some important points to make here. We feel more negatively about information that is cognitively dissonant, and there is evidence that anger, if people who are in a state of heightened anger tend to engage in more motivated reasoning. So some communication you create triggers a dissonant response. People are more likely to feel negative about it, and if, in particular, if it makes them angry, you can expect motivated reasoning in return, possible backfire effects. The nasty effect is unique to, not unique, but important in online spaces. And this is a finding from the research group I work in. Essentially, we did an experiment that's had individuals read a news article about science, and this article had been carefully written to include a balance of the risks of this emerging science and its benefits, and attempted to be neutral, focusing on the facts. And we exposed half of the participants to a comment thread that included ad hominem attacks and vitriol is very uncivil, and a comment thread in the other group that was more civil. The result was that individuals who saw the uncivil comments came away thinking that the article itself was biased. So this is disturbing for communicators of science, because even when you make your best attempt to provide what you think is just the facts, focus only on neutral presentation of the information people need to know, the emotional character of the conversation around what you're saying can actually make you look biased. So that's unfortunate, but also important to understand. So lastly, we are drawn to emotive content, even about science, and this content has also been shown to spread more quickly. So when we are communicating in discourses as science communicators and focusing largely on the facts, we might be losing a battle for eyes, attention, and hearts and minds if some of the other communicators in that space are communicating with much more emotionally laden content, and especially with greater outrage. So for example, consider anti-vaccination communities. If some of our messaging might fall flat, science-based messaging against some of that heightened emotion. Okay, so what can we do? Don't have a lot of time left, but I want to make sure we cover this. So one thing people have researched is this idea of establishing accountability. There's evidence that if you make people believe that they're going to be held accountable for their views, that they will reason more carefully. So for example, adding a reporter or a moderator to an online comment thread has shown to reduce incivility and produce more productive discussion among people. If that sounds expensive, consider that there's similar effects gained by signaling that there's accountability in this space, even if there isn't an active moderator. Just saying that there is has similar effects. You can warn people. So there's two maybe ways of doing this. One is that you can tell people about these kinds of biases that I've just discussed. So the idea that we have these psychological tendencies and we should be on guard against them has been shown in some cases to help people reason better and kind of mitigate those subconscious responses they might have. And you can also warn people that the particular space in which you communicate tends to have a lot of misinformation, so that, you know, readers maybe should be on guard against hearing certain kinds of things that are incorrect from other actors. Both of these have been referred to as inoculation approaches, and they are preemptive, and they have been shown to work. One thing to understand is that they don't always work, but they have been shown to be more effective than attempts to retroactively correct misperceptions. So if you can get ahead of things with some of these warnings in your communications, however subtle, that is potentially more helpful than the reverse. We can also package things based on people's values. So, and not trying to suggest that we are manipulative here, but just acknowledging that there are things, for example, with the example I gave about evolution and their religious groups, when you give people an opportunity in your communications to not necessarily have to defend their beliefs, but to say, like, according to the theory, to scientists, is, okay, I can recognize that this is what scientists know. No one's asking me to change my belief system definitively. They're just trying to give me information. That can be more successful. So one way of thinking about how to tailor things to people's beliefs is some efforts that people have made with climate change to try to connect their arguments about mitigation strategies not to environmentalist ideology or the value of the environment, but with Republican groups or conservatives, for example, to maybe focus more on the economic gains and innovation by the US. And that has been more successful. One other way of thinking about this is this idea of value pluralism, which is basically saying, do what you can with your message to make it less easy for an individual to just take a particular position based on their identity or value system. So rather than describing the conversation around human gene editing, for example, as one where, you know, religious groups tend to be opposed to this and scientists less so, and a religious recipient of that message might say, oh, well, I know where I'm supposed to stand then. You can make it less simple for people to use those kinds of shortcuts by highlighting the ways in which their specific value systems might actually experience some complexity, and they should think a little harder about it. So in human gene editing, for example, you could say that as religious individuals who have a moral imperative to try to save lives could see human gene editing this way, but others argue that there's a moral imperative not to mess with God's creation, and therefore they see it this way. And that has been shown to make people reason in more complex ways, and to kind of draw the most accurate conclusion for themselves rather than motivated reasoning. Finally, we could change some things about the character of social media spaces to focus less on impression management. So people will behave in particular ways, potentially uncivil ways, or engage in more motivated reasoning. They're trying to bolster a perception of their social reputation or specific image. So social media makes this especially pronounced because of things like likes and shares. So communications that maybe disincentivize some of those kind of social posturing tendencies could potentially be more effective at improving the discussion among people online. So for example, maybe not encouraging readers to like or share this and to engage with the content in different ways. So that's all I had. I think I'm a little bit over time. So here's my email. You're welcome to message me there. And this is the website for the research group in which I work, which, as I said, is Science, Media, and the Public, or SciMet for short. And I'm looking forward to talking with all of you in the Q&A. So thank you so much. And this has been great, even though we're virtual. All right, bye.